actually jumping back to section 5.2. So we went 5.1, 5.2, 5.4, and I'm going backwards to 5.2. Because I wanted you to have more time with the solving prior to Tuesday's quiz than just today. So I need to go over the problems like Jackson asked about that one for the bulb question. We really haven't done properties of exponents with fractions, so we need to do that really quickly. But we've already looked at properties of exponents in our intro section before we even started chapter 5. And then the other thing we need to do is simplify some expressions that have numbers and variables and roots in them. So we need to work on that as well. So the first thing I want you to write down is the fact that the properties of exponents, and if you look in your notes, you should have a section. It was like intro to chapter 5 or chapter 5 review. We studied all the properties of exponents. When do you add your exponents? When do you subtract your exponents? When do you multiply your exponents? Negative exponents flip things. Zero exponents are always equal to 1. And these same properties apply to fractions. So they're just less nice to work with because they're fractions. But the rules are always the same. When to add, when to subtract, when to multiply. So I've got a couple of examples here, and we'll try to decide what should we do with our exponents in each of these examples. So my first example is 13 to the 1/3 times 13 to the 1/6. The big question you would have to ask yourself, like on Tuesday's quiz, is, do I add, subtract, or multiply here? And sometimes if you're having trouble deciding what to do, I might take like this 13 to the 1/3 and 13 to the 1/6, and I might just give it like regular whole number exponents. What if it was just 13 squared times 13 cubed? What do you do with your exponents when you have the same base and you're multiplying them? You would add those, right? Because it's really like you have here, you have 13 times 13. And then for 13 cubed, you have 13 times 13 times 13. So how many 13s are you really multiplying? 5. Okay, so it's really 13 to the 5th, so you should add them. So the rule doesn't change just because they're fractions. I should keep my base, 13, and I should add in my exponent 1/3 plus 1/6. So I'm expecting you to go all the way back to elementary school when you learn to work with fractions. What do you need to be able to add and subtract fractions? Yeah, you need to have the same denominator. What's a good common denominator for 3 and 6? I would say 6. Yeah, you got to do the least amount of work. So we could multiply this 1/3 by 2/2. And that would really make it 2/6. So it's 13 to the 2/6 plus 1/6. And then that's 13 to the 3/6. I will want you on your quiz to go ahead and reduce that fraction. So 3/6 is really 1/2. And this is an okay answer. Some people might take 13 to the 1/2 and they might write it as the square root of 13. That's also totally fine. So I'll accept either answer. Everybody okay with that? Okay, so here's another example. What should I do with my exponents here? When dividing powers. Yeah, when you're multiplying powers, you add your exponents. So when you divide powers, you subtract your exponents. There is a question similar to this one on your homework, and I think a lot of people get caught off guard by this because they don't see 2 exponents. What is the exponent for 8 in the numerator? Just tell me.
1.
It's really just 8 to the 1st. So can you subtract exponents? Yeah. You just do 8 to the 1 minus 1/9. And on this one, I'm going to say, don't think too hard. What is 1 take away 1/9? Okay, nice. You had 9 nines, you had 1, and you took 1 away. So you have 8 nines. Sometimes people go through all the work of common denominators, which is fine, but I just think you're probably like making yourself just dislike math if you do that. 1 minus 1/9 isn't so bad. This is an okay answer. Some people may prefer to write it as the 9th root of 8 to the 8th. That's fine. So if you always want to change stuff into radicals, I'm okay with that. Either answer is acceptable to me. What would a problem look like if I was going to multiply my fraction exponents? How does it look different than the two on the board? Jackson? Yeah, you're talking about solving, so like to undo the fraction exponent, you would raise it to the reciprocal, and then you would end up multiplying them together. And think about like when I do that in a solving problem, what that looks like. There's a group of parentheses, right? So I could make up a problem right here and call it like, I'll use my first example, 13 to the 1/3, but then raise it to the 1/6. So know the difference between when to multiply and when to add. Okay, here I have one base and an exponent in parentheses raised to another exponent, so then I should multiply these. Okay, so if you want to write down an extra example so you can see when to multiply, you would multiply here. Do I need common denominators when multiplying fractions? No, I could just multiply across on top and multiply across on bottom. Some of you might work on like cross-canceling first just to reduce your simplification later. Okay. But I could write my answer as 13 to the 1/18 here, or the 18th root of 13. Either one of those is acceptable. Now, I'm not going to give you like super extensive problems with the properties and fraction exponents. So, you know, on the quiz on Tuesday, look for like, should I add my exponents that are fractions? Should I subtract my exponents that are fractions? Or should I multiply by exponents that are fractions? Those would be the big questions. Okay, next set of examples is a little bit different. It's just working on simplifying. Okay. And go ahead and write down this example in your notebooks, the cube root of 27d to the 12th. All I'm doing here is I'm introducing not just a number, but I'm adding like variables. Okay. We can simplify expressions with radicals that have variables in them. On Tuesday, I did a property of radicals that says if you have two radicals that have the same root, you can put them underneath the root together and multiply them together. And you can also separate them. So on this problem, I'm going to separate them. This is really the cube root of 27 times the cube root of d to the 12th. So that if like that were your original problem, you could put them under the cube root and multiply them together, and it'd be 27d to the 12th. Are we okay with me separating them like that? Okay. So now I want to actually simplify this expression. I can work one thing at a time. Can I do the cube root of 27? What is it? 3. And then to do the cube root of d to the 12th, this is in radical notation. Think about it if you were to change it into a fraction exponent. In the fraction exponent, the root is always where? In the denominator. So we would have times d to the 12 divided by 3, because the root is in the denominator. And then what's 12 divided by 3? 4. So our final answer could just be 3d to the fourth. Now think about that. If I took 3d to the fourth times 3d to the fourth times 3d to the fourth, so I multiplied it by itself 3 times. 3 times 3 is 9 times 3 is 27. And then if I were doing d to the fourth times d to the fourth times d to the fourth, what would I do with my exponents? Add them. 4 plus 4 is 8 plus 4 is 12. So when I multiply what I said was the cube root, I get that 27d to the 12. So I know that I was right. You don't have to do this for every problem. I'm just showing you, like, that's true. That's a check. Could you please do cube root of 64 y to the 6th for me? Think about how I did it. Break it up into the number and the y, rewrite with a fraction exponent, and then simplify as best you can. Did you guys get 4y squared? Not bad, right? Okay, now let me give you an extra one, just for fun. I'll do the 5th root of 32, a to the 5th, b to the 10th, c to the 15th. See if you can get an answer there. The 5th root of 32, a to the 5th, b to the 10th, c to the 15th. Since I added more letters, you have to break it up into more radicals, right? It's my hope that as we progress through the examples, like you don't have to write down all these radicals anymore. If you could just write them as the fraction exponents, okay, so that you're just reducing the amount of lines that you take up. Can you do the 5th root of 32? It is 2. Can you do the 5th root of a to the 5th? It is 5th root of b to the 10th? And 5th root of c to the 15th? Now, the last thing to discuss before you have some time to work on your homework. What if the exponent does not divide nicely? Like here I gave you 5 divided by 5, 10 divided by 5, 15 divided by 5. Yeah, what if it doesn't come out nicely? Okay, so I'm going to give you this one. We'll work this one together. The 5th root of 4, a to the 8th, b to the 14th, c to the 5th. We could technically go at this the same way, breaking it up using our product property for radicals and calling it the fifth root of 4 times the fifth root of a to the 8th times the fifth root of b to the 14th times the fifth root of c to the 5th. And maybe I would change these that are letters into fractions. So I'm really doing a to the 8 divided by 5, b to the 14 divided by 5, and c to the 5 divided by 5. What's really the only one of those that you like? C, because c comes down nicely, right? So that means that we'll be able to take the fifth root of c to the 5th, and c will come outside of the radical. But on the other ones, we might be able to simplify a little bit, but we're still going to have stuff that sits underneath the radical. It's just like when we do the factor tree and we have leftovers. Okay? So to write my final answer, I start by putting a fifth root there. So that now I can put stuff that comes out outside the root, and I can leave stuff inside the root. So I start one at a time. I'm going to start with the fifth root of 4. Can you do the fifth root of 4? No, and we don't have any perfect fifths that are factors of 4, so 4 stays inside. It's as good as it's going to get. Okay, we definitely can't do the fifth root of 8, or a to the 8th as it is, but when you're dividing 8 divided by 5, how many times can you get 5 into 8? Once. So that means we can take 1a, a to the 1st, outside of the radical. I can do the fifth root of a to the 5th. It's just a. So that can come outside. What's the remainder when you divide 8 by 5? 3. So there were 3 a's that didn't have enough to be like a group of 5, so they stay inside. So I'm going to write myself a little note. This is how many times 5 goes into 8. It is 1 time. And then this number right here is my remainder. So we can do the same thing with b. Well, b to the 14th over 5. If we divide 14 by 5, how many times can we get 5 into 14? 2. So we can take out a b squared. So the number of times it divides, its quotient comes outside. So a b squared. Is there remainder left over that don't have enough? How many?
4.
B to the 4th stays inside. And then we're at the one that we liked. C comes outside. Now you don't have to have this exponent of 1 on both of these. You could write your final answer as a, b squared c, fifth root of 4a cubed b to the 4th. Okay. Take out some, leave others inside. So if you wanted to try, if you have a question, Dana?
For example, like, wouldn't a be like 3? Yeah, 3 this.
Yes, but I'm going to want you to write it in the radical notation.
Oh.
So, yeah, he's saying like there's 3/5 left over, but is it 3/5 a fifth root of 8 to the 3rd? When we rewrite it, because the root is always in the denominator. So I think you're saying the same thing, but I'd like to see you write it as a radical. Can you try this one? The cube root of 2, a to the 13th, b to the 3rd, c to the 8th. Try that one, and then I'll give you your 10 problems for your homework assignment. Or you can work on flashcards, or you can work on the worksheet from Mr. Wrench. About what you can take out, what stays inside.
Oh, like when you divide 13 by 3, that's what we get. So 8 to the 4th comes out, and then the remainder stays.
So then you're supposed to do that.
Yeah,
And then check your C's. So that I really get like the division part of this, I like to rewrite my variables with the fraction exponent, because then that tells me exactly what I'm dividing. 13 divided by 3. 3 divided by 3. 8 divided by 3. Okay. So that helps me out in terms of what I'm doing. But my answer here I know is not going to come out nice, so I'm going to have a cube root that's part of my answer. And then I just start one by one. Can I do a cube root or 2? Nope. Stays inside. Can I do 13 divided by 3? Yeah, how many times does 3 go into 13? 4. So a to the 4th comes out of the radical. And what's the remainder? 1. So a to the 1st stays inside. For b, can I do 3 divided by 3?
Yes.
1 with no remainder, right? So b to the 1st is coming out. And then c, 8 divided by 3. 2 times, so c squared. And the remainder is 2, so c squared inside. You're done. Okay. So these numbers on the outside are quotients. Like 13 divided by 3, you start with 4. 3 divided by 3 is 1. And 8 divided by 3, you start with 2. And then the numbers on the inside for the exponents are the remainders.
What would b have a square?
That is just me writing terribly, because I ran out of room for erasing. I also thought for a second that it looked like I had a b squared, but I didn't. It's supposed to be a to the 4th, b, c squared. Okay, there are a couple questions on your homework assignment that will be similar to those last two. We will be reviewing on Monday, quiz on Tuesday.